All right, so I just wanted to give you guys a review from Monday so that you can complete the practice, just in case you were confused about a few things as far as properties with exponential functions. So what I'm expecting you guys to do is be able to find the base and the y-intercept in different formats, whether it be equation, a graph, or a table, and just be able to locate those pieces and put them together. So when I look at number one, well, let's first talk about the general format of an exponential. So when we talked about an exponential function, we said that the standard form or general form of exponential is a times b raised to x. Remember, a is your y-intercept and your b is your base. And the base is important because the base tells you whether or not it's growth or decay. So in order to be growth, it's going to have a b value that's greater than 1. If it's decay, then it's going to have a b value that's between 0 and 1. Okay? So when I look at number 1, it's in the format of an exponential because the x, or the variable, any variable, is in the exponent. And this is going to be my a value. This is my b value. So if I ask you to identify those pieces, you simply need to tell me that a equals 3 and b equals 5. Also, I want you to be able to tell me whether it's growth or decay and why it's growth or decay. So I'm always going to look at my b value. My b value is greater than 1, so I know this is growth. And if I ever ask you to explain, all you simply have to tell me is that my b is greater than 1, or you can say 5 is greater than 1, however, if you want to be more detailed. All right, so for number 2, for those of you that may not remember, we actually don't see an a value for this one, but I know it's still exponential because the x is in the exponent. So I have, if I were to rewrite this, I should know that there's an understood 1 in front. All right, and with my understood 1, that then tells me that that is my a value, and my 2/3 is my b value. So when I look at this, I know that a equals 1, so my y-intercept is 1, and my b is 2/3. And then, of course, 2/3, you need to be able to tell me that the problem is decay. And the reason that it's decay is because your b value is between 0 and 1. All right, so the next one is a different format, which is a graph. Remember, with graphs, you actually should be able to tell whether it's growth or decay based off the shape. So this is a J shape, and a J shape is actually going to represent growth. So I need to make sure that when I finish this, that whatever b value I find does represent growth. And the best way to do this is to go ahead and create a table of values. Just like we did with linear functions, you want to find perfect points. So in my table, I'm going to look for perfect points, which if I look at the first point, and always read from left to right, so I always go from negative to positive. So that one's going to be at -1 and 1.5, so 1.5. All right, and then I have another perfect point, which is at 0 and 3. Now, the y-intercept should be obvious because the y-intercept is always when the x value is 0. So this should be my a, so we're going to put a 3 here. And now we have to focus on what the base is, or the growth factor. And when you're doing this, you always remember the rule that I gave you was take the last and divide it by the previous. You're doing the inverse operation of multiplication in order to establish that. So the last number for your y is 3, and we're going to divide it by the previous. And 3 divided by 1/2 is going to be 2. So I know my base is 2. Okay. So if I asked you to write the equation, you should be able to write it as my y-intercept is 3, and then from there, every time that a new step x value happens, we're multiplying by 2. So 3 times 2 raised to x, which 2 is greater than 1, so that does represent growth. All right, number 4, we have another graph, but this one, if you notice, is L-shaped. And since it's L-shaped, that's going to represent decay. We should see that it is going down from left to right. So again, we're going to find perfect points. We're going to make our own table. So from left to right, I see a point at -1, 2, and I see a point at 0, 1. So again, my y-intercept is where the x value is 0. So I know that my y-intercept is 1. And to find my base, we're going to take the last and divide it by the previous in order to work backwards from multiplication. So my last was 1, my previous was 2, so I know that my base is 1/2. And 1/2 is between 0 and 1, so we know that that is decay. And when we write the equation, you can write 1 times 1/2 raised to x, but when you simplify it and actually look for the answer choice, it's going to have that 1 as automatically understood, so just y equals 1/2 raised to x. Alright, and the last thing we're going to talk about is a table, which, I mean, should be just as easy as the graph we did because you had to do the same thing. But in the table, you're always going to look for where your x value is 0, so that's automatically your A. So we know that the y-intercept is 5. And then to find our B value, we need to take our last and divide it by the previous. Now, I will say when we take the last and divide it by the previous, my last number is 5/4. And taking 5/4 and dividing that by 5 may be a little bit too much. You can always pick one number from the y and go by the previous. So I'm actually going to pick 5, and I'm going to divide that by 20. Make sure you simplify. So that's going to turn into 1/4. So my base is 1/4. So first thing I should be able to tell is that this is a decay problem, and it's decay because my base is between 0 and 1. And when I actually put this together as the equation, it's y equals 5 times 1/4 raised to x. I hope this helps, and I hope this kind of clarifies anything you may or may not have been confused about. If you have any questions, shoot me an email to kirkl@pitts.k12.nc.us, and I will try to respond as soon as I can.